Hello my people, we're doing well. We're going to, in this video, be concentrating on problems of the variety that you see in front of you, which, so basically maximizing or minimizing the distance from a point, finding basically the closest or the farthest point on a curve to a given point. Now this one, we actually have the graph here of y is equal to 4 minus x squared. And it asks, given the point 0, 2, what is the closest point on the curve? Now, what we want to do is we want to do the distance formula, right? Because we know the distance formula is basically just Pythagorean theorem in disguise. But let's just pick some random point on the curve, right? That right there will serve as sort of our any point. And you know that basically that distance is going to be the hypotenuse of this triangle. Okay? And so basically all we really need is to figure out, you know, x2 minus x1 and y2 minus y1, and those are going to be the legs. Alrighty, now the great thing about this is that the only thing that the radical is going to do is give you a denominator. So we're actually not going to be dealing with distance, but distance squared. And so we're going to be maximizing distance squared here. Now, our x2, y2 is going to be the point on the curve. Now remember, we don't usually think about this because an equation basically means that we're dealing with the sum total. Remember that an equation is an infinite relation, and a relation is a set of ordered pairs. And all the ordered pairs in that particular relation have the form x 4 minus x squared. And of course, our original is going to be 0, 2. So those are our 2 points, which means that if we use that to get our dx, we're going to have x2 minus x1, so x minus 0 squared, and then y2, 4 minus x squared, minus 2 squared. Now, like I said, if I did then put this, you know, to the negative 1/2, or to the 1/2, the only thing it would do is I would get this same thing to the negative 1/2 with a 1/2 in front of it. All it's going to do is give me a radical denominator, but the numerator is going to be exactly the same thing as if I differentiated this. So let's go ahead and do that. Let's actually simplify this first. This becomes x squared. And this inside here, this becomes x, squared. And then inside here, this is positive 4 and negative 2. So it's 2 minus x squared squared. Okay, so this is x squared. And then, of course, 2 minus x squared squared is the same thing as x squared minus 2 squared. So basically, we're going to do it as x to the 4th minus 4x squared plus 4. Which then simplifies again down to x to the 4th minus 3x squared plus 4. Now, let's go ahead and differentiate that. And we're going to get 4x cubed minus 6x. And that is going to be our derivative. Now, of course, we can pull out a 2x and I'm left with 2x squared minus 3. Once we've done that, we can go ahead and set that equal to 0. So 2x squared minus 3 is equal to 0. This is going to give me x is equal to 0. Okay, that's probably not going to be it, but we can, we can look at it, whatever. This basically is going to give me x squared is equal to 3 halves, and 3 halves, of course, is 6/4. And I only do that in order to go ahead and have a rational denominator when I take the square root. So the thing is that it's looking for the points. Because of the symmetry here and the fact that this point is on the axis of oscillation, I'm going to get 2 points that are equidistant from here, one on either side. And that's why we have the plus or minus root 6 over 2, if indeed it is not this x is equal to 0. Now, what we can do is we can go ahead and deal with it in terms of a sine chart, okay? And so if we want to do it in terms of a sine chart, we just need to remember the values. We need to remember the 0 and the plus or minus root 6 over 2. So let's go ahead and just make ourselves a big, nice, long line in order to set up the intervals. Now, let's go ahead and let's do, negative infinity to negative root 6 over 2. And of course, it's not going to be negative infinity, but you get the idea. X is equal to negative root 6 over 2, negative root 6 over 2 to 0, x is equal to 0, 0 to root 6 over 2, x is equal to positive root 6 over 2, and then root 6 over 2, off to infinity, I guess, or whatever. Now, all of these I need representative values for these. Now, it's helpful to know what the square root of 6 over 2 is, so I can actually find an appropriate value. Well, the square root of 1.5 is going to be between 1 and 1.5, but let's go ahead and take the square root of 6, and then let's divide it by 2, and it's 1.2. Okay? So I'm going to be plugging those in to my d prime. Now obviously all three of these gave me a 0. That's why they were critical values. Now if I plug in right here, if I plug in 1 into my derivative, and remember that my derivative function looks like this, and it's probably better to use it in its factored form, but it'll be easy to do the computation. On this interval, 1 is a representative value. So if I plug in 1, I'm going to get positive out here, but I'm going to get negative in here. And so I'm going to get a negative right there. Now, if I plug in negative 1, which is representative of this interval, I'm going to get negative and negative, positive. Okay, let's plug in, I don't know, let's plug in 2. Okay, if I plug in 2, I'm going to get positive and positive. If I plug in negative 2, I'm going to get negative and positive, and so basically this kind of does this number. That is a maximum, a local maximum. These are minimums, and we are trying to find the closest points, right? Closest to 0, 2. So it has to be those two values right there, okay? Now, let's go ahead, and basically when you plug those in, okay, the minimum or the minimum value or the minimum distance, basically the closest points, are plus or minus root 6 over 2, 5/2. Now, what I want to show you, however, is something pretty neat, because this you can use to actually check your answer. Now, if we look here, and of course we know that it's like 1.2, so let me get another color pen out. It's like 1.2, which is right about here, and then up to here. So it's this point right here, and this point right here. Okay. Now, notice that this graph has been stretched, right? So it's not actually to scale, and since this is kind of this over here is kind of crowded, so let me put it this way. Basically, the line connecting this point, your given point, and the closest point, the slope of that line will be perpendicular to the tangent line at that point. Let me repeat that. The slope of, and it doesn't look like it right here, like I said, because I've stretched the graph, but the slope of this will be perpendicular to the slope of the tangent line at that point. And you're like, surely not. Well, okay. let's go ahead and take a look at y prime. Remember, y prime, because it was y is equal to 4 minus x squared, y prime is equal to negative 2x. So y prime at root 6 over 2 is going to be negative root 6, right? Okay, let's go ahead and find the slope. Now this is at the positive, right? This is basically the slope of the parabola at root 6 over 2, the positive root 6 over 2, 5/2. Okay, well, how about the slope between 0, 2 and that? Well, that's going to be y2 minus y1 over x2 minus x1. 5/2 minus 2 is 1/2 over root 6 over 2. That looks like it's going to be 1 over root 6. Do you notice anything about the relationship between these two? They're negative reciprocals of each other. Coincidence? No, it's not. Okay, let's do another example, okay? Let's look at this one. Let's find the point, okay, that is on 1 over x that is closest to 2, negative 2. Now, 2, negative 2 is right here, okay? And so I'm looking for the point here, and I'm looking for a point on the curve, and we'll call that random point x, 1 over x. And this is 2, negative 2. So I simply need to find the distance between these two. So the distance between these two, okay, is going to be, okay, x2 minus x1 plus y2 minus y1, because plus and negative, minus and negative, it winds up being plus, so squared. Alrighty, let's go ahead and let's multiply all that out. Now I could go ahead, I guess, and do basically, you could basically differentiate from here if you wanted to. Well, let's go ahead and do that. So we have 2 times x minus 2 plus 2 times 1 over x plus 2. And this one didn't have anything out here as the derivative of the inside because it's just 1. But this one actually does. We need a negative 1 over x squared. Now, if that's the case, then this whole term right here is negative. And when I set this equal to 0, that sends this over to the other side. And of course, I can also divide through by 2. So if I do 0 is equal to 2, x minus 2, and we'll sort of clean this up a little bit, minus 2 over x squared, 1 over x plus 2. I can go ahead and divide through by 2, and then I can add this one over to the other side. And I get 1 over x squared, 1 over x plus 2 is equal to x minus 2. Now, I need to multiply through by x cubed in order to get rid of both of those denominators. And when I do, what I'm going to get is I'm going to get 1 plus 2x is equal to x to the 4th minus 2x cubed. Now, if I have that, now I have 0 is equal to x to the 4th minus 2x cubed minus 2x minus 1. Now, finding the zeros of this are a huge pain in the neck, so I'm not going to go through all of that with you. But if I were to give this to you on the test, it would be a derivative where it was easier to find the critical values. But I will go ahead and let you in on a little secret. Basically, 1 plus root 2 is one of the zeros of this quartic function. And basically, you need to go ahead and, so if x is equal to 1 plus root 2, well, 1 plus root 2 is approximately 2, because it's 1.414 is root 2, so it's 2.414. Okay? Now, that as an input corresponds, of course, to the 1 over x, so you're basically looking at the point 1 plus root 2 and then 1 over 1 plus root 2 as the ordered pair, which minimizes the distance. Okay? If you're thinking to yourself, surely not, and surely that whole perpendicular thing doesn't work this time around, oh, let us take a look. Now, remember that y prime, okay, is equal to negative 1 over x squared, because y was equal to 1 over x. If I take the y prime at 1 plus root 2, it's going to give me negative 1 over 1 plus root 2 squared. Now, 1 plus root 2 squared actually simplifies, and I won't go through it, but it simplifies to negative 1 over 3 plus 2 root 2. Okay, well that's kind of neat. Let's go ahead and do the slope between the 2 points. Now remember, my 2 points were 1 plus root 2, 1 over 1 plus root 2, and the original given point, which was 2, negative 2. What is the slope between those? Okay, how about y2 minus y1 over x2 minus x1? Okay, well, that's, let's go ahead and multiply through by this denominator, by this 1 plus root 2 over 1 plus root 2. By the way, this simplifies to 1 minus root 2. Isn't that convenient? Now, when I multiply through by this, remember that this needs to be distributed both to that nasty rational-ish construction right there, and to the negative 2. So I'm going to get negative 2 minus 2 root 2 minus 1, right? And of course, these two first terms are when it was distributed to the negative 2. That negative 1 is when it was distributed to here because it was intended to cancel out the denominator. That was kind of the point. Well, this winds up looking a whole lot like conjugates of each other, so this just winds up being 1 minus 2, and this winds up being 3 plus 2 root 2 over 1. Well, you look at that. Okay? And basically that gives you a way of checking. And of course, you could also use that to actually find the point. But seeing as we're actually trying to use the derivative to do so, but let's go ahead and let's see how that looks just in general, okay? Can I make a general statement that that is always the case? Well, I am making that general statement. I'll go ahead and back it up right now. Let's go ahead and take a look at this. Now, let's say that I want to maximize or minimize, okay, distance from a point to a curve, okay? That is what I'm looking for. And I'm basically going to be given AB as a given point and y is equal to some f of x expression, which of course tells me that every ordered pair on that curve is x f of x. Now I know that basically what I've been doing is without the radical, I've been doing the x2 minus x1 squared plus y2 minus y1 squared. And so let's just do the y2 minus y1 squared plus x2 minus x1 squared. Now we can go ahead and take the derivative. That winds up being 2 f of x minus b times f prime of x plus 2 times x minus a. Now when I set that equal to 0, the 2's are going to disappear, and I'm just left with f of x minus b times f prime of x plus x minus a. Okay, let's go ahead and subtract the x minus a from both sides. Okay, now let's go ahead and divide through, and we're going to get f prime of x is negative x minus a over f of x minus b. But we can also reason that the slope between the 2 points is f of x minus b over x minus a. This is the slope which makes this minimum. This is the slope on the curve which makes all of this a minimum. Okay? Now, this is the slope between the 2 points. Notice anything? Yes, they are reciprocals of each other. Okay? Now, let's go ahead and do one more now that we've seen the general principle. This one is going to be a little bit different because of the way it's curved and the fact that you're actually picking a point that is on the curve. You're actually looking for the point that is farthest away, but it's the same thing, okay? The only problem is that basically you're going to have to choose whether you're going to think about it in terms of the positive or the negative, because you have to have an ordered pair. So let's just deal, because there's symmetry, right? And so whatever the farthest point is up here, it's also going to be mirrored down here. So let's just concentrate on the one up here in the positive. And so let's go ahead and solve for y. We get y squared is equal to 4 minus 4x squared. Okay? And then y is equal to plus or minus 1 minus x squared. But since we are dealing with just the top half, and we're going to basically use symmetry to extrapolate to the bottom half, we'll just leave it like that. Now, we have dx, right? Oh, by the way, this means that every point on the curve, on that top half of the curve at least, is going to have this form. And that means, okay, that basically we're going to have, okay, we're going to basically do the distance between these 2 points. So x minus 1 squared plus 2 root 1 minus x squared minus 0 squared. Well, that's awfully nice. That just means that it's basically just going to be that squared, and that's going to be the undoing of that radical. You get x squared minus 2x plus 1 plus 4 times 1 minus x squared, or x squared minus 2x plus 1 plus 4 minus 4x squared. That gives me, when I simplify, negative 3x squared minus 2x plus 5, and the derivative of that is negative 6x minus 2. By the way, that's going to give me a critical value of x is equal to negative 1/3, which actually works just as well for the top as it does for the bottom. Okay, and that means that the points that are farthest away are negative 1/3 and plus or minus 4/9 root 2. Now, do you think that basically the slope at those points, let's go ahead and just draw them. This is 2.4, 0.6, so between 0.2 and 0.4, it's up here at negative 1/3, so it's going to be right about there, and then basically right about here. Okay? Now, if I want the slope here and the slope here, let's just go ahead and look at just the top half again. Or actually, let's go ahead and just, let's differentiate it implicitly. That's fine. 4x squared plus y squared is equal to 4. We have 8x plus 2y, y prime is equal to 0, and therefore y prime is equal to negative 4x over y. Now, if I use y prime at one of those points, let's use the top half one, 4/9 root 2, I'm going to get negative 4 times negative 1/3 over 4/9 times root 2. Well, those cancel, the 4's cancel, and I basically have simplified it at least a little bit down to that, which is 1/3 times 9 over root 2, or 3 over root 2. Now, the line that connects, okay, now remember, we're going to compare this to the line that connects between 1, 0 and negative 1/3, 4/9 root 2. we're going to have 4/9 root 2 minus 0 over 1, negative 1/3 minus 1. So you're going to have 4/9 root 2 divided by negative 4/3. So 4 root 2 over 9 times negative 3/4. The 4's cancel, 3 inside the 9 cancels with that 3, and I'm left with negative root 2 over 3. There you go. Negative reciprocals of each other. Okay. Now the negative reciprocal part is not necessary in terms of finding the answer. I just thought you'd kind of like to see it, and for those of you who actually work rather quickly, it provides you with an opportunity. It gives you something to check your answer with, and that's actually kind of nice. Okay. I'm going to go ahead and call this video to a close. If you have any questions, as always, please do shoot me an email. Bye.